Welcome to The Explainer. Today, we're going to add an absolutely crucial tool to your programming toolkit by mastering one of Python's most powerful and versatile features, the list.
So here's the game plan. We're going to build this up step by step. We'll start with the absolute basics, like what even is a list, and then we'll level up to some really cool, powerful techniques like slicing and dicing your data.
Okay, first things first. Let's get right to it and answer that big question. What exactly is a Python list? And maybe more importantly, why is it something you're going to use constantly in your code? So think about this for a second. In your code, you're not always just dealing with one thing at a time, right? Not just a single name or a single number. What happens when you have a whole bunch of related things? How do you keep all that stuff organized and easy to get to? Well, Python's answer to that problem is just really elegant. It's the list. Think of it like a container, a box you can put all your stuff in. But it's a special kind of box. The two big keywords to remember are ordered and changeable. Ordered just means the position of every item matters. And changeable, well, that's its real superpower. It means you can mess with the list after you've already made it. Add things, remove things, switch things around. It's incredibly flexible.
All right, enough theory, let's get our hands dirty. We're gonna build our very first list and then figure out how to, reach inside and grab the exact items we want.
And creating a list couldn't be easier. Seriously, all you do is use a pair of square brackets and then separate each item with a comma. Done. In this example, we've got a list of strings, but, and this is what makes them so awesome, a list can hold pretty much anything. You can mix and match numbers, strings, you can even stick other lists inside of a list.
So how do we get stuff out of the list? Python gives us two really clever ways. First, you can count from the beginning using what's called zero-based indexing. Yeah, it trips people up, but it just means you start counting from zero. So the first item is at index 0. But here's the really neat trick. You can also count backwards from the end using negative numbers. So -1 is always the last item, -2 is the second to last. It's a fantastic shortcut. There's another handy tool you should know about, the list constructor. It sounds kind of formal, but all it does is take something iterable. And don't worry, iterable just means anything you can loop through, like a string of text. And it automatically breaks it down into a list of its individual pieces. So as you can see, you feed it the name Jessica, and bam, you get a list with each letter as its own item.
Okay, making lists is just the beginning. Like we said, their real power comes from the fact that they aren't static, they're mutable, which is just a fancy way of saying we can change them. Let's see how that works.
Now, before you start modifying a list, it's often super useful to know how big it is. The built-in len function is your go-to for this. You just wrap your list in len, and it instantly tells you the total number of items inside. Simple as that.
To change an item, you just target its index and assign a new value just like you would with a regular variable. So here, we're targeting index 0, which holds Python, and we're just overriding it with JavaScript. Boom, the list is updated. Okay, quick heads up. You are absolutely going to see this error at some point, index error. When you do not panic. It's not a failure. It's just Python's very helpful way of telling you, hey, you tried to access a spot that doesn't actually exist in this list. Think of it as a useful guidepost, not a scary error.
Need to get rid of an item completely? The del keyword is what you're looking for. You just point it to the index you want to remove, and that item is permanently deleted. It's important to know that when you do this, everything after it slides over to fill the gap, so their index numbers will change.
So let's do a quick recap of your new toolkit. You can get the length with len, you can update an item by its index, you can delete an item with del, and you can even do a quick check to see if something is in the list using the in keyword, which just gives you back a simple true or false.
All right, with the fundamentals down, let's explore a couple of what I like to call power moves. These are techniques that will make your code way cleaner and more efficient. We're talking about nesting and unpacking.
You can totally put lists inside of other lists to create more complex data structures. To get to the items buried inside, you just chain the index numbers together. So developer2 gets us that inner list of programming languages. Then we just tack on another -1 to get the second item from that list, which is Rust. Now, unpacking is a fantastic Python shortcut. Instead of accessing each item by its index one by one, you can just assign all the items in the list to individual variables in one single clean line of code. It's so much more readable and efficient. And it gets even cooler. By putting an asterisk, that little star, in front of a variable name, you can pull out a specific item, like the first one here, and then have Python automatically gather everything else into a brand new list. This is incredibly useful when you only care about the first few elements and want to deal with the rest later. And just like that index error before, if you ever see a value error when you're unpacking, it's not a bug. It's just Python's friendly way of telling you that the number of variables you're trying to assign to doesn't match the number of items in the list. It's a safety net that keeps your code predictable.
For our final tool, let's look at one of the most elegant and widely used features of Python lists, slicing. This is how you grab portions of your list without messing with the original at all.
Slicing lets you grab a subsection of your list. Use a colon to separate the start and end points. Now, the most important rule of slicing to remember is that it goes up to but does not include the end index. So a slice of 1,4 is going to grab the items at index 1, 2, and 3, but it stops before it gets to index 4.
And slicing has one more trick up its sleeve. You can add a third number, called a step. In this example, we're starting at index 1, leaving the endpoint blank to go all the way to the end, and we're providing a step of 2. This tells Python to grab the item at index 1, then skip 1, grab the next, skip 1, and so on, giving us a list of 2, 4, 6.
So there you have it. You've got a really solid foundation now for creating, accessing, modifying, and slicing lists. But this is just the beginning. The next step is to explore what are called list methods. These are powerful built-in actions that let you do things like sort your list, reverse it, or dynamically add new items. And that's where you'll really take your skills to the next level.